homework today?
There are 5, actually the homework is, the hard part is understanding this. The homework is going to be shockingly fast and easy. It's 5 problems. And I'll be adding to it tomorrow, so nothing's due tomorrow. So I will do that thing where I'm like, hey, you can do these 5 tonight, but if you don't do them, you'll have time tomorrow and it won't be due. All right, so we're going to be coming up with 6 addition formulas, but today we're only going to be coming up with 2. We're just going to do the cosine ones. So we're going to do this one and this one today. Now, normally, not normally, you know how I try to make a point of like explaining any formula I'm going to use and why it happens? And there are going to be some formulas in this class where literally I'm just going to hand you the formula and be like, look, let's just use it, okay? Because it takes a lot of work to try to derive these formulas. But this one I'm actually going to take a really difficult formula and I'm going to derive it. Okay, look at me. Look at me because I'm serious. Hey, you never have to be able to derive this formula on your own. Ever. Okay? So what I'm about to teach you is not something that you ever have to reproduce. You do have to be able to know how to use it, which we'll also do in this lesson. But I'm going to derive a formula with you, and I'm just trying to give you experience so you can see what mathematicians actually do. Okay? Where they go, how they think. A really difficult proof is what we're about to do. Again, you never have to do this on your own, but it is important that occasionally I show you something that's really difficult so that you can see what it's like. Okay? All right, so why are these called the addition formulas? Half of them are subtraction. Anybody know? Right, so write down that subtraction is the same thing as adding a negative. So really, we'll call them all addition formulas. Anybody know what the word derive means? Like when you're deriving a formula? It means creating a formula using other formulas or math facts. So basically it's like, I know this other math thing, so now I can make another conclusion. Does anybody happen to remember the distance formula? What'd you say? That is the formula for like a line, like the equation for a line. Yep. Do you know how that came about? Yes, good on you. All right, so we're about to derive what you're talking about. Have you done this before, Emma?
On my own.
Cool. Ugh, cool. All right. So let's say that we're trying to find the distance between, we're going to pick 2, 7. Doesn't have to be perfect, just right. This is 2, 7. And we'll go with this one, which is -6, -1. Now, I'm sure that you guys have used the distance formula before. Remember doing that in a different class, maybe? Finding the distance between 2 points. Okay? But we're actually going to prove why it works. So, I'm going to, right now, and so are you, turn this into a right triangle. What is this distance here? 8. Between 7 and -1, that's 8. Were you doing like a math equation in your head, or were you just like looking at it? 7 above, 1 below is 8. But if I was going to write a math equation, what would I write? Like if I had to type it in my calculator to figure it out, what would I write?
7 plus
7 plus a -1 would be 6.
Shoot.
7+1.
Right, I could write 7 plus 1, but this is a minus 1, so I would probably write 7 minus a negative 1, which would make 7 plus 1, right? Okay, how about this side? What's this equal to? 8. We could do it with 2 minus a negative 6 makes 8. Or 2 on this side, negative 6 on that side, right? Okay, so how would we find this side? A squared plus B squared equals C squared, so that is 8 squared plus 8 squared equals, I'm going to call this D for distance, D squared. That's what, 64 plus 64, which is what?
128.
128 equals D squared. And then to get D by itself, you take a square root, you take a square root. Okay, so this is us just doing it without actually, which is like 11.3 something. This is just us doing this without actually doing any kind of formula whatsoever. So now we're going to generalize it. Okay, ready to generalize it? I'm going to call this one x1 and y1. I'm going to call this one down here x2 and y2. And you said that to find this distance here, we took 7 minus a negative 1. So I'm going to rewrite that as that was what? Y1 minus y2. Do you guys understand what I mean by generalizing? I'm basically saying, look, instead of saying it's specifically 7, I'm going to call it y1 now. What would this one be? X1 minus x2. And if I'm going to do the Pythagorean theorem with those, I would say that parentheses x1 minus x2 squared, that's the bottom, plus y1 minus y2 squared, that's the side, equals d squared. Do you see how I'm using the Pythagorean theorem to make the distance formula? How do I get d by itself right now then? How do I get rid of a square? Square root. Okay, so that's the distance formula. D equals the square root of x1 minus x2 squared plus y1 minus y2 squared. And the nice thing about a formula is that I no longer have to draw a picture. I can just have 2 points and just plug this stuff into here and then just use it. All right, raise your hand halfway if you feel like, I think I understand where the distance formula came from. Okay, that's a lot of us. All right. Now that is kind of an easy proof compared to what we're about to do. What we're about to do is we're going to find out cosine of a minus b. And to do this, I'm actually going to do it with circles. And I'm going to try to talk slow, and I'm going to try to take my time. But for both of these spots, you're going to need a circle. And I also want you to make it into like a unit circle. So we're going to have like the axes that are going like right through the center. It is way easy to draw the axes after you draw the circle, fair warning.